Hello and welcome to A-Level Math. This is the third video in the series Trigonometry, and this video and the videos that we'll be covering after this video, these cover the major portion of the syllabus, or rather the questions that you will be going to encounter in your examination. So make sure that you are getting a very good understanding and you try to remember all the formula that we discussed in this video and in the subsequent videos. In order to look at the previous videos in the series Trigonometry, just click on the I button above. So let's start. As of now, we have discussed some basic formula. So sine of a plus b is sine a cos b. Let me write it down. So we have discussed sine of a plus b is equal to sine a cos b plus cos a sine b. And we have also discussed sine a minus b is equal to sine a cos b minus cos a sine b. Alright, now what if you add these two identities? So if I add these two, what I'll be having is that these two terms, sine a cos a sine b and minus cos a sine b, these two terms are going to get cancelled out. So what we'll be having in the left hand side is just this plus this, because we are adding it over here. So it's sine a plus b plus sine a minus b is 2 sine a cos b. So this is the third formula that you will have to remember. Remember, I told you that there are more than 70 or 75 formula in the entire trigonometry chapter, and you have to memorize all of these. And the best way, believe me, the best way to memorize all of these formula is to know the derivation of each and every one of them. I told you, just mug up those two formulas starting with sine a plus b and cos a plus b, and just remember these two formula. And I strongly insist to derive each and every formula that you use after that. So just remember, just memorize. Don't go into the proof of sine a plus b, sine a cos b plus cos a sine b. I give you the freedom to mug up this as it is. If you are interested, and I insist, you should go through the proof of it. But all you have to start with is these two formulas, sine a plus b and cos a plus b, and therefore thereafter you have to derive all these formulas, so you will have a better, so it will be helping you memorize all these formula for the long term. All right, so this is one more formula added to the list. Sine of a plus b plus sine of a minus b is 2 sine a cos b. And most of the times we use it in the reverse order. So you will be given 2 sine a cos b, and then you will have to write it down as sine of a plus b plus sine of a minus b. Most of the times it will be used in the reverse order. So we'll see examples covering this. But for now, take my words for granted that try to remember 2 sine a cos b is sine a plus b plus sine a minus b. That means for 2 sine cos is sine plus sine. Remember it like this: 2 sine cos is sine plus sine. So it will help you remember all these things. Okay, 2 sine cos is sine plus sine. All right, now we already know these two things as well, that cos of a plus b is equal to cos a cos b minus sine a sine b. Remember, when we are having plus over here, we are having a minus in between, and cos of a minus b is cos a cos b plus sine a sine b. Now again, what if we add these two things? So when we add these two things, these two terms get cancelled out, right? Sine a sine b and minus sine a sine b, they get cancelled out, and what we are left with is this: cos of a plus b plus cos of a minus b is 2 cos a cos b. All right, so in a similar fashion, you will have to remember in the reverse order, because that will be mostly used in solving questions. 2 cos a cos b is cos a plus b plus cos a minus b. So try to remember that 2 cos is actually cos plus cos. Okay, sorry, yeah. So 2 cos is actually cos plus cos. So we have got two more formula. One is this, 2 sine cos is sine plus sine, and another one is 2 cos cos is cos plus cos. So that we got by adding the previously known equations. But what if I subtract these two equations instead of adding this? So like instead of adding these two equations, not equations, rather identities. So instead of now adding these, what if I subtract these? So I change all the signs. So instead of these terms getting cancelled, instead of these things getting cancelled over here, what we have is this thing getting cancelled. All right. So what we'll be left with is sine a plus b minus sine a minus b. You just subtract it like any ordinary equations. You remember you tried out elimination methods for solving equations. It's just the same thing. Sine a plus b minus sine a minus b is equal to 2 cos a sine b. And again, try to remember it in the reverse order. 2 cos a sine b is sine a plus b minus sine a minus b. So what you have to remember is this: 2 cos sine is sine minus sine. Alright, so 2 sine cos is sine plus sine, but if it is 2 cos sine, then it is sine minus sine. And similarly, if you subtract these two equations as well, I'm straight away writing down the results and I leave it to you to prove it. So what we'll be having is cos a plus b minus cos a minus b is equal to, so when we subtract, if you notice that, then we are having a negative and these two terms are getting cancelled out, and we are having a negative, so we get a minus and minus. That means we get a minus 2 sine a and sine b. So what we can do, we adjust this minus by changing the signs everywhere. So we make this plus, we make this plus, we make this minus. We can change, we can multiply with a negative one on both sides. So you can think of like it like that as well. So throughout the equation we multiply with a minus 1. So what we have is effectively this cos a minus b minus cos a plus b is 2 sine a, it will be 2 sine a sine b, 2 sine a sine b. So remember, we are having a minus first and then plus, just because for minus we actually have both the plus, right? So it's in the minus we have plus and plus, that is why we keep it first. So 2 sine sine is cos minus cos, but remember this order: negative first and then positive ones. Okay, so this is what we have in the left hand side. Okay, so what we do, we multiply and divide with a 2, and then we copy the entire thing again. So you see how we introduce this 2 forcefully by adjusting it to the half, because half and 2 is if you multiply them you'll be getting 1, and 1 multiplied by something doesn't change it. So this is how we forcefully get a 2 over here. All right. Okay, so now you can use this 2 for applying the formula. So what we have is now 2 cos a cos b. So you can think of this 20 as a and 40 as b, and then move. So what we do, we write half outside and then we take 2 inside, 2 cos 20 cos 40. So this can be applied into our formula, and then we leave those two things as they are for now. We don't touch them. So let's see what happens when we apply the formula over here. So 2 cos a cos b, can you tell me the formula? Bad boy, don't remember it. So 2 cos a cos b is cos a plus b cos a plus b plus cos a minus b. This is what cos gives, right? 2 cos is cos plus cos, and then you keep this entire thing and then multiply it with cos 60 cos 80. Okay, because this is going to be multiplied with this entire thing, right? So this is why brackets are important. So you keep half as it is. This cos 20 plus 40 can be written as cos 60 plus cos 20 minus 40 is cos of minus 20, but remember cos minus theta is cos theta, so we just have cos 20, and then we leave those things as they are, cos 60, cos 80. Okay, now what we can do is that we know the value of cos 60, right? Cos 60 is actually half, so we can plug in the value of cos 60. So I've erased the above parts. So what we can do is put down the value of cos 60, which is half, plus cos 20 remains as it is, and again cos 60 is half, so I multiply this half with this half and make it 1 by 4. I can do that, and then cos 80. Okay, so now what I do, I take this cos 80 and multiply it with each of these two terms. Alright, so 1 over 4, 1 by 2 cos 80 plus cos 20 cos 80. Okay, so if you see, we again have something of the form cos cos, so we'll have to bring in that 2 forcefully. So what we can do, we can multiply this again with a half and 2. So what we do, we make this 1 by 4 as 1 by 8, because we additionally multiplied with a half, and then we multiply each of these terms with a 2, so it's actually multiplying with a half and a 2. Okay, so 1 over 8, this 2 and 2 gets cancelled out over here, so we get cos 80 plus 2 cos A cos B is cos A plus B plus cos A minus B. I hope you understand this thing. Okay, it's just the previous, it's just the sort of the previous line that we did. Okay, so it's 1 over 8 cos 80 plus cos 100 is not known to us, so let's keep it as it is for the time being, and this cos 60 is again half. Okay, now let me erase this. Okay, now think about this cos 800. So cos 100 can be written as 180 minus 80, right? So we can write this 180 as 90 times 2 minus 80. Remember the very first part of the trigonometry that we covered? So 90 times 2, so this 2 is something even, so cos remains cos, and we have to and this is just cos 80, and now we have to determine its quadrant. So 90 times 1, 90 times 2, and again back minus, so in the second quadrant. In the second quadrant, cos is negative, so it becomes minus cos 80. Okay, so if you haven't watched the video, please do watch the first video on trigonometry series. You'll understand this better. So what we do, in place of cos 100, we write down minus cos 80, because they are both equal. So cos 80 minus cos 80, and then plus half. Cos 80 gets cancelled out. Ooh la la, nice. So 1 by 8 times 1 by 2 is 1 by 16, which is actually the RHS. Proved. Okay, some more examples, but before that we have to understand some new formulas. So we have found out 4 new formula as of now, and now 4 more formula, because I told you this is the chapter transformation of sums into products. So what we have just covered is products into sum. Now we'll be actually covering sums into products. So you'll be given something like sine plus sine, and then you will have to convert it into something of the product, sine cos or cosine or whatever. Okay, so let's first write down with what we know. We know that sine A plus B plus sine A minus B is 2 sine A cos B. This we have just covered. Okay, so what if I, in place of A plus B, I write down C, and in place of A minus B, I write down D. Okay, so quickly we can solve these to find out the values of C and D. So if you add these two equations, so you'll be having 2A is equal to C plus D, So C plus D is by 2 is actually A, and if you subtract these two equations, then you will be having A and A cancelling out. You'll be having 2B is equal to C minus D, and C minus D by 2 is equal to B. So these are the two things that we'll be getting if we take A plus B as C and A minus B as D. And now what we do is just substitute these values. I mean, in this identity, in place of A and B, I replace everything in terms of C and D. So in place of A plus B, I write down C. So because A plus B was C, and in place of A minus B, I write down D. So it's sine D is equal to 2 sine. In place of A, I can write down C plus D by 2 because we have just derived it. So it's C plus D by 2, and in place of B, I can write down C minus D by 2. So see how we are deriving one formula from the other in a sequential manner. I told you, remember, you just start with the very two basic formula, the formula of sine A plus B and cos A plus B, and thereafter you have to derive each and every one of them in so that it will be fixed inside your mind and you will never forget it. Believe me, if you write these things down yourself, if you prove these things yourself with pen and paper, you will never forget this, trust me. So that is why I'll always insist, make sure that you are always writing down the proofs of those formula. Okay, so we have got a formula for sine C plus sine D, which is 2 sine C plus D by 2 cos C minus D by 2. So this is how we will transform any sum into a product. See, this is product. So before this part, we just did the exact reverse thing. We converted products into sum, and now we have known a formula for converting sums into products. Okay, so I'll write down 3 more formula and I leave it to you to prove that those formula will actually hold true. Okay, if you still can't, it is given in any standard textbook that you are following. In any book you will find the proof, but I insist, please go through it and make sure that you are writing it down on pen and paper yourself without seeing it. Okay, try it out. Okay, so let me write down the other formula. Sine C plus sine D is okay. Sine C minus sine D is 2 cos C plus D by 2 sine C minus D by 2. Okay, let me give you a hint. So what if you write down the second formula, sine A plus B minus sine A minus B, then you had something like 2 cos A sine B, right? And then just plug in the values of A plus B and A and B in terms of C and D, and that's it. Sine C minus sine D is 2 cos, we have already discussed got the value of A, C plus D by 2, and sine B is sine C minus D by 2, and that's it. Nothing more than that. It's as simple as that. Okay, so cos C plus cos D is equal to 2 cos C plus D by 2 cos C minus D by 2. So in order to prove this, you start with the formula cos C plus D plus cos C minus, you start with cos A plus B plus cos A minus B is 2 cos A cos B, and then just substitute these values for A and B. Alright, and finally cos C minus cos D is 2 sine D plus C by 2 sine D minus C by 2. Remember that we are doing D minus C over here. It's because of the fact that there is some problem with that A and B, right? It's not A minus B, it was negative terms first and then the positive terms. So make sure that you are practicing it. It's only then that you will understand why this is not C minus D, why this thing is not C minus D, and why this is D minus C. It's only then that you will understand why is this happening. Okay, alright, so formula at a glance. Make sure that you are remembering these formula, because I'll be taking a few examples considering the application of these formula. Okay, so take a screenshot or remember them, whatever you want. Okay, let's move on. We have to prove that these things hold. Okay, so let's start with the left hand side. Always most of the times we start with the complicated one and then try to simplify it. So the complicated one is the left hand side over here, so we start with the left hand side. Okay, so cos c plus d is 2 cos c plus d by 2 cos c minus d by 2, and then we just replace it over here. It's 2 cos c plus d by 2 in cos c minus d by 2, and then in the denominator we'll again have to apply the formula, but this time the formula is sin c minus sin d, because this sin minus sin, so sin c minus sin d is 2 cos c plus d by 2 sin c minus d by 2. Okay, so it's 2 cos c plus d by 2 sin c minus d by 2. Okay, so just have to consider this as c, this as d, c d, that's it. So let's simplify. So you see, this 2 and 2 will get cancelled out, and this cos is exactly the same as this cos. What we are left with is cos 6x minus 4x is 2x by 2 is x. So this is cos x by sin 6x minus 4, 2x by 2 is x. So this is cos x by sin x, which is cot x, and which is the right hand side, and we are done. We have proved it. Some more examples. Okay, again let's start with the left hand side. Okay, so this is the left hand side. So what you do, you take these two first, because it's having a 2 over here, so let's not touch it because it might give you some problem. Okay, so what we have is sine plus sine, because they don't have anything else with them, so let's just take these two for the time being. So sine 5x plus sine x, so sine c. Okay, so this is the left hand side. So what you do, you take these two first, because it's having a 2 over here, so let's not touch it because it might give you some problem. Okay, so what we have is sine plus sine, because they don't have anything else with them, so let's just take these two for the time being. So sine 5x plus sine x, so sine c plus sine d is 2 sine c plus d by 2 cos c minus d by 2. This is the formula. Okay, so sine 5x plus sine x is 2 sine c plus d by 2 cos c minus d by 2, and then you keep this minus 2 sine 3x as it is, don't touch it. Now the denominator, this is cos minus cos, cos minus cos is 2 sine d plus c, remember d plus c by 2 sine d minus c by 2. So remember, cos minus cos has that d and c play around it. So d plus c, it's not d minus, it's not c minus d, it's d minus c. So in order to remember the formula, instead of c plus d we call it d plus c, even though this part doesn't make any change, c plus d or d plus c doesn't make any difference, but for the ease of remembering the formula I call it 2 sine d plus c by 2 sine d minus c by 2. Okay, you can call this as c plus d also, doesn't matter. Okay, so let's simplify quickly. 2 sine 5x plus x, 6x by 2 is 3x, cos 5x minus x 4x by 2 is 2x, minus 2 sine 3x whole divided by 2 sine x plus 5x is 6x by 2 is 3x, and sine x minus 5x is minus 4x by 2 is minus 2x, so this is sine minus 2x. Okay, so 2 and 2 gets cancelled out, sine 3x and sine 3x gets cancelled out. What we are left with, I'm sorry, so there is a negative over here, so we have to first factorize the numerator. I'm sorry. So let's keep these, make these things alive again. Okay, they are alive, and now you take 2 sine 3x common in the numerator. We cannot cancel out without factorizing. Okay, cos 2x minus 1 divided by 2 sine 3x, and sine minus 2x we can take minus outside, we can write sine 2x, and now we can make these things killed, we can kill these things. Okay, so what we are left with finally, let me delete something, I'll delete it from this. Alright, so what we are left with is cos 2x minus 1 divided by minus sine 2x. Now what we can do is we divide sine 2x with each and every one of these terms. So cos 2x by minus sine 2x minus 1 by minus sine 2x. Okay, so cos by sine, cos 2x by sine 2x is cot 2x, so we get minus cot 2x, and we can make this thing as plus, because minus and minus will give us a plus. So it's plus 1 by sine is cosec, so it is cosec 2x, and we just write it in the form of a gentleman. This is not a gentleman forms of writing. It's cos 2x minus, sorry, it's cosec 2x minus cot 2x, which is the right hand side, and we are done again. So see, you have to remember those formula, because in each and every step, it might happen that sometimes we are applying the formula in the same question 2 or 3 times or even more than that. So make sure you have a good grip on all those formula. Okay, one more question. Sin x plus sin 3x plus sin 5x plus sin 7x is this. Okay, so let's start with the LHS first. So now what we can do, you just take the first and the last term together and the middle these two terms together. Okay, this will help you reach the destination a bit faster. So you will understand as we progress why are we taking terms like that. See, if you take x and 7x, the total is 8x, by 2 is 4x. So remember, you'll be having those c plus d by 2. So here x plus 7x by 2 is 4x. Similarly, 3x plus 5x is 8x by 2 is 4x. So we are getting 4x, and try to keep the angles, these are actually angles, right? X, 3x, 5x. So try to keep those angles same throughout as much as possible. This is a hint that you should keep in mind. So always try to keep one angle and keep try to convert everything into one single angle as much as you can. It's not always, of course, possible, but try to keep this thing in mind. Okay, so you take the first and the last term. So sin x plus sin 7x together. So we'll be applying formula in this case, and also we'll be applying the same formula for these two terms. Sin x plus sin 5x. It's sin 5x. Okay, sin c plus sin d. Tell me the formula. Incorrect. The correct formula is sin c plus sin d is 2 sin c plus d by 2 cos c minus d by 2. This is the formula. Now sin c plus sin d is again 2 sin, this was 3x, I'm sorry, sin 3x plus 5 sin c plus sin plus d by 2 cos c minus d by 2. Okay, so now you simplify things. 2 sin x plus 7x by 2 is 4x, cos x minus 7x minus 6x by 2 is minus 3x, plus 2 sin 4x cos 3x minus 5x is minus 2x, by 2 is minus x. So 2 sin 4x, remember cos minus theta is cos theta, so cos minus 3x is just cos 3x, plus 2 sin 4x cos x, cos minus x is cos x. Okay, now what you can do, you take 2 sin 4x common. So 2, that's why I told you try to bring in the common angle as much as possible. 2 sin 4x cos 3x plus cos x. Okay, Now again apply the formula for this. So it's 2 sine 4x, and what is cos c plus cos d? It is 2 cos c plus d by 2 cos c minus d by 2. So it's 2 sine 4x remains as it is, 2 cos 3x plus x is 4x by 2 is 2x, and cos 3x minus x is 2x by 2 is just cos x. You can multiply this 2 and 2 together to make it 4 sine 4x cos 2x and cos x. This is what we are required to prove. This is the RHS, the right hand side, and we are done again. Okay, so question after question, question after question. I hope it helps you. Okay, cos x plus cos y whole squared. So again, let's start with the left hand side. Alright, so this is the left hand side. Now there are two things you can think of. So the one approach is that in the first side you will have a hunch to open the squares. So you will make it cos square x plus cos square y plus 2 cos x cos y, and you also open the square up here. Okay, so you can of course do that, and I think you'll be getting the answers in that case as well. But what I feel is that, you see, in the right hand side we have to convert this into x minus y by 2. So I, from the very beginning, I have a hunch that what if I convert this into the formula? What if I convert this sum into a product? This will, as it is, give me x minus y by 2. So I will try that way. But if you want, you can go the other way also. Remember, not just getting the answer is not what you should do. Also, sometimes you think of, why if I move in the other way, why am I not getting the answers? So things like this will help you. So if you're not getting an answer in some way, it will help you. It will give you insights into future. I mean, when you will be tackling similar questions, not exactly the same question but similar questions, then you will already know, okay, I went in this direction and this was the problem that I was getting. So this will always make you better prepared in order to start with any question. So it's not always in the examination that you'll be getting the questions that you have already done. You'll be getting sometimes similar questions as well. So it's always good to try to think in different directions for the same question. This will help you a lot in the examinations. It will save a lot of time of yours when you get some new question in the examination. That is what that takes time. But prepare for the best and for the worst both. Okay, so what I do, I apply the formula over here. So it's cos c plus cos d is 2 cos c plus d by 2 cos c minus d by 2. So this is x minus y by 2 I'm getting. So that is why I had a hunch that, okay, I should apply the formula first and then square it up. But if you want, you can square it in the first step as well. Now sin c plus sin d is 2 sin c plus d by 2 cos c minus d by 2. Okay, and the square of this. Alright, so now you square. So these are the product of three terms. So square will get on each of these terms. That is 2 square 4 cos square x plus y by 2 cos square x minus y by 2 plus 4 sin square x plus y by 2 and cos square x minus y by 2. Alright, so what we can do, we can take this 4 and cos square x minus y common. Okay, so 4 cos square x minus y by 2 common. What we are left with is cos square x plus y by 2 plus sin square x plus y by 2. Okay, so this x plus y by 2 is some angle. Okay, so you can consider this x plus y by 2 as theta. So what we have is cos square theta plus sin square theta, and we know that the value of this thing is actually 1. So what we are left with is just this quantity, because multiplication with 1 doesn't change it. So we are left with 4 cos square x minus y by 2, and that is our answer, the right hand side. just two more formula. I promise these are the last two. We have already discussed 4 plus 4 8 formula in this tutorial, and now just two more. Please bear with me. Okay, I'm sorry, but I have to complete this. All right, so sine a plus b into sine a minus b. It's not plus, it's not minus. This time it's multiplication. What do you get if you multiply these two things? Sine a plus b times sine a minus b. Okay, pause the video for some time, try it out, expand these results. You already know the value of sine a plus b and sine a minus b. Just put them and then multiply them and see what you get. Okay, cheating, you're not pausing. Okay, I'll do it. Sine a plus b is sine a cos b plus cos a sine b. This we know, sine a plus b, and sine a minus b we also know, sine a cos b minus cos a sine b. Now you have to multiply. So think of this entire thing as x, this entire thing as y. So this is also x, this is also y. So this is x plus y into x minus y. We know what is it? We know that it is x square minus y square. X plus y into x minus y is x square minus y square. Just put on the values. Okay, so you'll be having sine a cos b the whole squared minus cos a sine b the whole squared. Alright, now this gives us sine square a cos square b minus cos square a and sine square b. So what we do, we convert everything into sine. So sine remains sine, sine square a. Cos square b can be written as 1 minus sine square b. Cos square a is 1 minus sine square a, and this remains sine square b. Now we open up the brackets, sine square a minus sine square a sine square b minus sine square b plus, because this minus and this minus will be plus, sine square a sine square b. So minus sine square ab plus sine square a sine square b, and then finally we are left with is sine square a minus sine square b. So this is the formula for sine a plus b times sine a minus b. So this you have to remember, add it to your list. This is one more formula, and also we can write another form of this. If you write sine square a as 1 minus cos square a and sine square b as 1 minus cos square b, then this 1 and 1 will get cancelled out, and what we are left with is cos square b, because minus and minus will be plus, cos square b minus cos square a. So remember, sine a plus b into sine a minus b, there are two formula. One is sine square a minus sine square b, another one is cos square b minus cos square a. And similarly, I leave it to you as an exercise to prove that this result will also hold. Cos a plus b into cos a minus b is cos square a minus sine square b, and another formula for the same thing is cos square b minus sine square a. You just write down the values or the expanded versions of these two, multiply them, simplify them as we did before, and the answer will follow. So there are two more formula, in total 10 formulas covered in this video. Now some examples. Alright, sine square a minus sine square b. So think of this 6x as a and 4x as b. So we are having sine square x 6x minus sine square 4x. So we remember that sine square a minus sine square b can be written as sine a plus b into sine a minus b. So what we do here is we take the LHS, and we can write the LHS as sine a plus b multiplied by sine a minus bn. One step more for simplification, sine 10x times sine 2x, and this is what the RHS is. Done. Okay, so a quick recap of all the formula that we have covered so far in all the previous videos. So till now we have covered 3 videos, and all the formulas that we have discussed so far are this, but believe me, there are more to come. But we will keep a track of all them, and we will keep to memorize all of them by deriving them, by uh, solving by writing down all those formulas and deriving them on pen and paper. That is the best way you can remember those things. So if you want, you can take a screenshot of it, and also the PDF version of this formula is provided in the description box, so please do check it out. And that's it. Thanks a lot. Study hard, study smart, and keep studying with A level maths. Bye bye.